Good morning, students. Last class we saw that applying ampere circuit law loop enclosing surface. Okay, so this is a balloon type of loop, and then there's a two plate. Then one plate connected to the positive charges in the voltmeter. Next negative charges connected to that negative terminal to the voltmeter. Okay, so now you are passing through the current through to that plate. So here that loop, the balloon, like that balloon loop, it's not having to that charge. Okay, so now we are now we consider to that equation closed surface. So closed surface B vector dot dl. Okay, the closed surface. So the surface we are taking to the S2. You see that we are taking to the S2. That surface magnetic field B vector dot dl vector. So now we are considering that already the magnetic field equal to that mu naught, right? So that mu naught I. So you are flowing to the current. So here no balloon, it's here not having to the balloon, it's not having to that flowing of the current. So the IC equivalent to 0. Okay, so IC equivalent to 0. So for this term fully we are considered to the 0. So the closed integral surface B vector dot dl vector equivalent to 0. Okay, now you see that hence there is on the inconsistency between the equation. Okay, so this is the inconsistency of the equation. So now you see that JC Maxwell resolved this the inconsistency. Okay, what he doing means due to the external source. So what he is thinking to, he is giving to some of the external source through the battery or cell or capacitor also get the charge of the because of the current flowing through the capacitor. Okay, the capacitor we are to using and apply to the current. This produce and increasing the electric field between the capacitor plate. Okay, so what happened here? You see this picture, the balloon picture here having to that voltage voltmeter giving the sum of the current. It's flowing to the plate, capacitor of the plate. So here having to the positive charge, the positive charge always the increases. So here the voltmeter is giving to the negative charges. So here also the negative charges is here increases. So that times what happened, the two plate in between the what happened, the magnetic field, that is a electric field, the changing the magnetic field produced to the electric field. So here it is what happened here, more than charges passing. Okay, the both side is a more than charges passing. So increasable, the through two plate is increasable of that charges, electrical field charges. So that the this side, the two plate in between having that insulator, some of the insulator material having already I told So that side what happens here, it is here making to that electrical field. It's in that electric field increase ஆகுது. இந்த both பிளேட்லையும் electrical charges increase ஆகும்போது இந்த in betweenல இருக்கிற அந்த கேப்லையும் electrical flux create ஆகுது. Electrical flux, it's creating that electrical flux create ஆகுது. ஓகேவா? So now you see that in the place, in the IC, in the current, the wire la IC current, total of the IC oda current எப்படி இருக்கும்னா IC I equivalent to IC plus ID. Okay, IC constant current plus displacement of the current. Okay, so now you see that here not having to the displacement of the current. Okay, appo you have to taking the ID equivalent to 0. So you see that I here written that, so IC plus 0. So you are calculate that IC. Okay, so I equivalent to IC only. So ID equivalent to 0. So now here also the increasing that current means the negative charges, electrons increases here, this capacitor means what happened, I equivalent to IC plus ID. So here the constant value what is 0. Why means here increase of the electric flux. Okay, so appa ID, the displacement is a moving of the changing of that. Yeah, so appa ID values come. So the constant current is here 0. So equivalent to I equivalent to ID. So this side we are taking to the I equivalent to ID. Okay, wow. So this is the values. So now you see that after we are taking to that Gauss law, after we are after we see that, you see that from the Gauss law we are taking that the electrical flux between the plates of the capacitor. Okay, wow. So now you are using to the Gauss law. So the pi of E means electrical field, right? So integrate the closed surface integration of the E vector dot dA vector. Okay, so now that closed surface, this is here we are taking to that E A. Okay, A va differentiation panna A, inge number of E and that E abdi. So the EA value already we are, you know that Gauss law la Q by E epsilon Q by E naught. Okay, Q by E epsilon naught. Okay, wow. So next you see that pi. So that the pi E would have value equivalent to Q by epsilon naught. Okay, change in the electric flux. After we change the electrical flux, after we changing to the electric flux in the interval of the time. Okay, after changing the electrical flux changing the electrical flux in the depend on the time. Okay, wow. So dq d pi E electrical, okay, by dt, d pi E by dt equivalent to d by dt. Okay, wow. So inga in the value pi E would value electric field. Okay, pi electric field in the value here clear, and the value na inga substitute panikiren. D by dt into Q by epsilon naught. Okay, wow. So next na enna panna, the 1 by epsilon naught in the side kondu varen. Okay, wow. Okay, eppadi na kondu varena, inga Q the 1 by idu split panni write panikiren 1 by epsilon naught dq by dt. Okay, so next we get the value. Next ipa cross multiplying the 1 by epsilon naught in the side na kondu varena epsilon naught dq d pi E by dt. Okay, pi d pi value dq by dt enu kadachidum. dp in the values full value enakku enadhu current displacement. So current displacement value q dq by dt. Okay, otherwise we are taking to that id equivalent to epsilon naught d pi E by dt. Okay, wow. So this is the displacement of the current. Okay, wow. So now you see that the displacement current can be defined as the current which comes into the play in the region in which electric field and electric flux are changing within the time. So displacement of the current which is the electric field and the electric flux are changing within the time. This is amperes. Okay, wow. So next you see that Maxwell equation. So next you see that Maxwell equation. Okay, wow. So the Maxwell equations here, 4 types there. You see that electrodynamics can be summarized into the 4 basic equations. So the Maxwell equation in the integral form. The Maxwell equation the 2 form irukku, integral form one irukku, another one is a derived form. So 2 types of the form irukku. So now we are discuss about the integral form. Okay, wow. So the derived form you are studying to that college level. Okay, wow. So now engineering level you have to study the derived form. So now that the electrodynamic law can be summarized into the 4 basic equation having the Maxwell equation integral of 4 basic equation. So one is this equation or analogy to the Newton equation, the mechanics. Okay, the Maxwell equation complete the example in the behavior of the charges, currents and properties of the electric and magnetic field. Okay, charges, behavior of the charges, second one currents, third one property of electric and magnetic field also. Okay, so now you see that first one is here we have to using to the Gauss law. Okay, first equation nothing but that Gauss law. It is related the net electric flux. It is a related net electric flux to the net electric charger enclosed in the surface. So mathematically we have to write into the closed surface area electric field dot dA. This is closed surface area. Why we are putting A means the area of the surface, we have to put the A. So Gauss law, you know that Q by epsilon naught, it's a Gauss law. So that the capital Q enclosed we are writing there. Okay, this is a Gauss formula. Next you see that here E vector is the electric field and Q enclosed is the charge enclosed. This equation is true for both discrete or continuous disruption of the charges. Another discrete or continuous is a distribution of the charges. It is also indicate that the electric field lines start from the positive charges and terminal at the negative charges. So second point you see that electrical field lines start from that positive charges negative terminal charges. That implies that electric field lines do not form a continuous closed path. So the electric field lines do not form the continuous closed path. So in the not a closed loop. Okay. So other words in the means of the isolate positive charge or negative charge can exit. Okay. So next point you see that second equation has a no name, but this law is similar to the Gauss law. This law is similar to the Gauss law. So electrostatics. So the law can be also called the Gauss law in magnetism. So Gauss law in the magnetism. So the surface integral magnetic field over the closed surface is a 0. So always the closed surface is always the 0. Already you know that integration closed surface of the integral B vector the dA vector equal to 0. So y is 0 now, the mu naught, the current is equal to always the 0. So that B vector is the magnetic field. Okay, so B vector is a magnetic field. This equation implies that the magnetic lines of force form a continuously closed path. Continuously it's a closed path only. So other words that means that no isolate magnetic monopoles exit. Okay. So next you see that wait 1 minute. Anyway, so next you see that third point. Third, the equations of Faraday law, electromagnetic induction. The law relate the electric field with the changing the magnetic flux. Okay, electric field, changing the electric field produced the magnetic flux. Okay, magnetic flux. Okay, so it's a mutually, the mathematically we have to return this formula. You see that Faraday laws, already you know that Faraday. The closed surface integral E vector dot dl vector equal to minus d by dt. It is a time, variation of the time pi b. Pi b means a magnetic flux. Okay, so it is a Faraday laws. Okay, this Faraday laws we have to using. Okay, next you see that where E vector is the electric field. E vector is the electric field. This equation implies that the line integral of the electric field around any closed surface path, it's equal to the rate of change of the magnetic flux on the closed surface value. Magnetic of surface value, it's equal. Okay, in the surface. Our modern technology revolution is due to the Faraday's law of electromagnetic induction. The electric energy supplies to our houses from the electricity supplied to our houses from the electricity board by using Faraday law of inductions. Okay, so fourth one you see that fourth one we are compared to that modify to the Ampere laws. Okay, modify to the Ampere laws. Now you see that calculations Ampere laws. So now you see that this is an Ampere equation. Already you know that Ampere equation. Closed integration surface V vector dot dl vector equivalent to mu naught I enclosed. Okay va. So modify the ampere circuit. Modify the ampere circuit. In the ampere circuit நம்ம modify பண்ணணும். Okay va. So modify பண்ணும்போது இந்த magnetic flux magnetic field dl இருக்கு. this closed surface area ல. So இதனுடைய value equivalent to the mu naught. So mu naught IC plus ID. So to the constant current and displacement of current. So the mu naught உள்ள multiply பண்ணுங்க. அப்போ mu naught IC plus mu naught ID. Okay. So now you see that mu naught IC equivalent to mu naught அப்படியே வச்சுக்கோங்க. ID ஓட formula. Already we are. So the previous section we have to find out to that. Okay va. ID the ampere laws at the displacement. இங்க okay va. The displacement we have to find out. Okay, this value. ID equivalent to mu naught d pi e by dt. So in the value we have to apply to here modifications la. Okay, ID oda value la inga apply pandrom, right? So next you see that and next so next you see that so integrate mu naught IC plus mu naught E இதை வந்து பிரித்து ரைட் பண்ணுங்க, பிரித்து எழுதுங்க. இந்த ஈக்குவேஷன் நம்ம எப்படி மாடிஃபை பண்ணலான்னா mu naught E naught, the mu naught E naught d by dt. Okay, integration pi e. So pi e ஓட வேல்யூ ஆல்ரெடி we know that find out பண்ணியிருக்கோம். லாஸ்ட் செக்ஷனில் find out பண்ணோம். integration closed integral surface E vector dot ds vector. So இந்த ஈக்குவேஷன் I will split பண்ணியிருக்கேன். So this equation equivalent to the integration of the modification of the ampere circuit law. So it is the ampere circuit law. Okay. Next electromagnetic waves. So electromagnetic waves. Now you see that your book having to the diagram. So I am here drawing to the one diagram. So this is a easy way to your understanding. Okay. So now we are discuss about the production of electromagnetic waves. So properties of the electromagnetic waves. Next class we will see. Today we have to discuss the production of electromagnetic Hertz experiment waves. Okay va. The Maxwell prediction was experimentally confirmed by the Heinrich Rudolf Hertz. So in 1888 the experimental setup you are using and verify to that electromagnetic waves. Okay va. So first he was taking to that two metallic electrodes. You see this is a two metallic electrodes. Idanide metallic electrode, one positive, one negative. Okay, this is a two small metallic electrode. Okay va. So and this is a small spherical metals also. Okay va. It's a small spherical metals also. Okay, so now you see that they are connected to a large the two metal small spherical electrode. We are connecting to the two large spherical metals. Okay, this is here connected to the large. Okay, so next you see end of that. So in the spherical small spherical உடைய எண்டில் வந்து நான் என்ன பண்ணியிருக்கேன்னா ஒரு பிக் அதாவது லார்ஜ் ஸ்பெரிக்கலை கனெக்ட் பண்ணியிருக்கேன். இண்டக்ஷனை வந்து என்ன பண்ணியிருக்கேன், கனெக்ட் பண்ணியிருக்கேன். ஓகேவா. ஸோ நெக்ஸ்ட்டு இதனுடைய எண்டில் ஓகேவா. ஸோ திஸ் end we are connected that. So next you see the end of them are the connected to the induction coil with very large number of turns. So next you see that some of the distance I kept into the one large induction of the idanadu large induction of the number of turns coil. இதானது ரொம்ப லார்ஜாக இருக்கும். இது வந்து EMF ப்ரொடியூஸ் பண்ணோம். இது வந்து நிறைய நம்பர் ஆஃப் டேர்ன்ஸ் காயில் இருக்குது. இதில் வந்து நம்பர் ஆஃப் டேர்ன்ஸ் இருக்குது. ஓகேவா, இதுதான் காயில். ஸோ இந்த காயிலை கனெக்டட் டு தட் த ஸ்மால் எலக்ட்ரோலைட்ஸோடைய கனெக்ட் பண்ணியிருக்கேன். ஒன் இஸ் ஏ கனெக்டட் ஹியர், அனதர் ஒன் இஸ் கனெக்டட் தேர். ஓகேவா. ஸோ இப்படி கனெக்ட் பண்ணியிருக்கேன். ஓகேவா. ஸோ நவ் இட்ஸ் எ வெரி லார்ஜ் high value of it's a produced to the high electromotive, that is a force. that is a EMF force. It's a produced through the I value of EMF force. Okay, so next, since the coil is a maintained, it's at very high potential. So this coil is a very high potential. Okay, wow. So it's a passing to that high voltage. Okay, so now you see that the two metallic ball, the spherical ball, in between having the small gap. So in the small gap having to that some of the air. Okay, wow. So what happened, the current is here passing, the electrode it's a passing here, the current passing to the electrode. What happens, the in between having to the air is here, electrode gets ionized. So what happened here, here converted to the ionized. So the air oda in the electrode வந்து என்ன ஆகுது, என்ன ஆகுதுன்னா அயனைஸ்ட் ஆகுது. ஸோ இது வந்து அயனைஸ்ட் ஆகுறனால இங்கே ஸ்மால் ஸ்பார்க்கல் க்ரியேட் ஆகுது. இட்ஸ் கிரியேட்டிங் டு த ஸ்மால் ஸ்பார்க்கல். அதாவது ஸ்பார்க்கல் மீன்ஸ் டிஸ்சார்ஜ் ஆஃப் த எலக்ட்ரிசிட்டி, டிஸ்சார்ஜ் ஆஃப் த எலக்ட்ரிசிட்டி. ஸோ இந்த இடத்துல ஏர் இருக்குது, இந்த டூ மெட்டாலிக் எலக்ட்ரோலைடோ பாலுக்கு மின்பின்ல இந்த ஸ்மால் ஏர் இருக்குது, கேப்பில் இங்கே ஏர் இருக்குது. whenever you are high voltage EMF you are produce பண்ணும்போது, force produce பண்ணும்போது ஆட்டோமேட்டிக்கலி இங்கே என்னது ஸ்பார்க்கல் க்ரியேட் ஆகுது. ஸோ இந்த ஏரோட இந்த EMF force அப்ளை ஆகும்போது இட் ஈஸ் ஏ கிரியேட்டிங் டு த சம் ஆஃப் த ஸ்பார்க்கல். ஸோ அதாவது ஸ்பார்க்கல்னால் என்னது, அந்த நெருப்பு துளி வந்து கிரியேட் ஆகுது அந்த இடத்துல. ஓகேவா. The gap between the electrode closed and a small gap kept at the distance also get the spark. So அப்புறம் என்ன பண்ணுறோம், next you see that the apparatus some of the distance I kept the one of the small electrolyte, ஒரு small electrolyte ஒரு சர்க்கிளில் என்ன பண்ணுற கனெக்ட் பண்ணியிருக்காங்க. சர்க்கிளில் என்ன பண்ணியிருக்கேன், ஒரு கனெக்ட் பண்ணியிருக்கேன். ஸ்மால் electrolyte spherical balls connect பண்ணியிருக்கேன். ஓகேவா. whenever that here the EMF of the force whenever you are connected to that electrolyte, here the passing to that sparkle அது கிரியேட் ஆகும். அயனைஸ்ட் ஆகி இந்த ஏரோடைய அந்த EMF of force அயனைஸ்ட் ஆகி ஸ்பார்க்கலை ப்ரொடியூஸ் பண்ணுது. இந்த ஸ்பார்க்கல் ப்ரொடியூஸ் பண்ணும்போது ஆட்டோமேட்டிக்கலாக இது என்னது டிரான்ஸ்மிட்டட் ஆகுது. எங்கிறது, இட்ஸ் இம்ப்ளைஸ் த எனர்ஜி இஸ் அ டிரான்ஸ்மிட்டட் ஃபார் த எலக்ட்ரோட்ஸ். ஸோ இங்கே என்ன ஆகுது, இங்கே ஒமிட் பண்ணுற ட்ரான்ஸ்ஃபர் பண்ணுற எனர்ஜி இங்கே கெட் பண்ணுது. ஓகேவா. ஸோ இங்கே சம் ஆஃப் த டிஸ்டன்ஸில் இருக்கிற இந்த காயிலாம் என்ன ஆகுது, get to that energy. Okay, so that times what happened, the two metallic ball in between are some of the gaps, the small gaps is here ionized. Again it's ionized. After that here produced to the sparkle. It's produced to the sparkle. So இதே வந்து ஒரு 90 டிகிரியில் இதை ரொட்டேட் பண்ணி வச்சுக்கணும். இந்த ஆங்கிள் இதை ஒரு 90 டிகிரியில் ரொட்டேட் பண்ணும்போது it is not produced to the sparkle. இது வந்து sparkles produce பண்ணாது. Okay, this confirm that the electromagnetic waves are transfer waves. So electromagnetic waves, whenever it's creating the electromagnetic waves, that waves is here what happened, இங்க வந்து sparkle produce ஆகுதுன்னா electromagnetic waves தான் sparkle produce பண்ணும். ஓகேவா. So electromagnetic waves create the electric current and the sparkle also. ஓகேவா. அதுக்கு எலக்ட்ரிக் கரண்ட்டை க்ரியேட் பண்ணும்போது ஸ்பார்க்கலையே ப்ரொடியூஸ் பண்ணுது. ஸோ அந்த எலக்ட்ரோமேக்னட்டிக்கை ட்ரான்ஸ்ஃபர் பண்ணும்போது ஏர் வழியாக ட்ரான்ஸ்ஃபர் ஆகும்போது இந்த இடத்துல என்ன ஆகுது, இட் இஸ் ஏ கிரியேட்டிங் டு த ஸ்பார்க்கல். த எலக்ட்ரோமேக்னட்டிக் வேவ்ஸ் அப்சர்வ் பண்ணும்போது ஆட்டோமேட்டிக்காக அந்த எலக்ட்ரோட எதை ப்ரொடியூஸ் பண்ணுது, ஸ்பார்க்கலாக ப்ரொடியூஸ் பண்ணுது, டிரான்ஸ்மிட்டர் ஆகுது. இதுவே 90 டிகிரியில் நம்ம வைக்கும்போது ரொட்டேட் பண்ணோன்னா இதை 90 டிகிரியில் ரொட்டேட் பண்ணும்போது இட் இஸ் நாட் ஏ ப்ரொடியூஸ் த sparkle. ஓகேவா. ஸோ it's defined to the Maxwell. Hertz detected radio waves and also compute the speed of the radio waves. So the Hertz detect the radio waves and also the computed the speed of the radio waves. This radio waves equal to the speed of the light. This radio waves உடைய speed equal to that light speed. So 3 into 10 to the power of 8 meter by second squared. Okay, I understood. I hope you are understood. It's a very important question coming to that 5 mark. Thank you, children.